Hey guys, so in this lecture we are going to mainly focus on the problematic discussion which are asked in GATE, IES, those kind of things. So let's see the first question. So a BJT is biased in forward active mode. Assume VBE which is equal to 0.7, KT by Q is 25 millivolt and reverse saturation current IES which is equal to 10 power minus 13 milliamps and transconductance of the BJT. So they are asking what is the transconductance in the BJT. So please pause the video and try to answer it. So let me give one more clue. The transconductance, which is generally stated as GM, so that will be directly proportional to dou IC divided by dou VBE. So this is the formula that we can use to derive. So please pause the video and try to answer. If you guys have find the answer, please post in the comment section. So we know that IC, which is equal to IS e power VBE divided by eta VT minus 1. So here IC, IB, which have a relationship, so we have to differentiate this thing. So if we differentiate this thing, then we will get IS which is equal to constant. So E par anything is the same. So one can be differentiate, we can ignore it. So if we differentiate E par thing, so we will be getting E par VBE divided by eta VT. The constant term which need to come below. So that is 1 divided by eta VT. So that is 1 divided by eta VT. So minus 0. Okay. So now this 1 by SE IEC which can be also be equal to, so which is nothing but that is approximately equal to IC. So which can be now approximately written to, so prox equal to IC divided by eta VT. So GM, now we are able to get the formula for GM, that is IC divided by eta VT. So normally we take eta which is equal to 1. So now the GM formula which is equal to IC divided by eta VT. So if you guys haven't got the answer in the previous thing, so please use this answer and pause the video right here and try to answer it. So okay, so this is one kind of shortcut that we can use to find the GM. So this is majority of the case, but here there are specifically given the answer. So let me try with this one itself. So the GM which is equal to IS e power VBE divided by VT. I took eta is equal to 1 and VT. Okay, so if we substitute the thing, so IE which is equal to 10 power minus 13. So why I am using this formula is that they are given IS and other related information. So if they directly want us, so we can use IC or eta BT, but IC also we don't have. So we don't have anything, so we have to use this one way. So 10 power minus 13 into e power 0.7 divided by 25 milli, that is 0.025. Okay, so divided by 0.025. Okay, so this is the thing. So if we use the calculator and try to answer it, so the GM that we will be getting here is the, so GM which is equal to 5.76 milliampere divided by voltage. So in GATE and IES calculator is allowed, so please use this one. I think in IES calculator is not allowed, so there you have to remember some kind of thing, or in the question they will mention some kind of shortcuts, so that you don't need to worry about thing. So this is how we can calculate the GM. So I hope you guys able to find out how we can calculate this answer. So if you guys have any difficulties to solve this one, see, please post in the comment section. For sure I will be giving you or guiding you with some kind of shortcuts there. So if you guys feel that it is difficult or can't get it, so I will be giving another one session, or I will be trying to post anything to make it. So here is the second question. So an NPN transistor having reverse saturation current of 10 power minus 15 is biased to forward active mode, same mode. So VB is equal to 0.7 or 700 milli. So VT is 25 milli, same configuration. So here you see the current gain beta, which can vary from 50 to 150 due to manufacturing effect. So they are asking us to find out IE max. So at what configuration the IE will be max. So that is what the question. So let's directly take our condition. We know only one formula, that is IC which is equal to IS e power VBE eta VT minus 1, right? So if we take approximation proximity and remove the minus 1 here, so then will be equal to VBE divided by eta VT. So IC can also be written as alpha E. So this is based on the, we know the formula, right? So this is in the alpha, that is the thing in the common base mode we have the thing, right? So alpha. So now this can be also rewritten as IE which is equal to 1 divided by alpha IC. So we know IC and we know alpha. So let me use the formula of beta here. So 1 divided by beta divided by beta. So why am I using beta here is that we have the detail for only beta. So IC can be now written as IS e power VBE divided by VT. Okay. So this is what the formula that we are going to use. So let me even simplify this one. So this can be even written as 1 divided by beta plus 1 is e power vbe divided by vt. Let's taking thing. So we know that beta is coming below. So if we took 150, so if the beta is higher, then IE will be decreasing. So for lower voltage of beta only, IE will be max. So let's take beta which is equal to 50 because it is in denominator. So we have to see IE need to be max. So that is what we have to calculate it. So when we take beta is equal to 50, then only IE will be max. So IE max can be calculated here. So that is equal to, so if we apply 50, that will be cross multiplying. So 51 divided by 50 into 10 power minus 15, that is given in question, e power, I am taking the millivolt and cancelling the milli. So 700 milli and 25 milli, so milli cancelling. So if you use the calculator here, so we will be getting answer that is 1.475 into 10 power minus 3. So they are clearly asking in microamps. So let's move 3 points away. So then it is 1475.1 microamps. Okay. So I hope this is very simple one. So if you guys know the formula and simple logic behind it, you guys can able to clearly achieve it. Okay. So this is one of the very important questions. So you guys can please make a note of it. So let me go to next question. So for a BJT, the common base current alpha, which is the alpha they are given. So alpha which is equal to 0.98. And the collector base reverse saturation potential. So that can be also written as ICBO. So this is common base. So I am writing as ICBO. So this is 0.6 microamps. Okay. So IB they are given. So IB which is equal to 20 microamps. The BJT is connected in common emitter. So now they are changing the configuration. Okay. So now they are changing the configuration. So they are changing into common emitter mode and operating in octave with the base current of IB. So this is one set of configuration. So this is another set. So they are asking collector current in the common emitter mode. So this is one of the important question. So let's see how we can relate the things. So let me take red color. So we know that IC which is equal to beta IB. So we can also add one parameter that is ICEO because this is common emitter mode. Okay. So we need to relate ICEO with IBV. So we have a relationship. So this one that is equal to ICEO which is equal to 1 plus beta ICBO. So this is one of the important formula. So how we have seen for reverse breakdown voltage, right? So 1 divided beta. Similar to that, the 1 plus beta is the term that we need to take into picture. So if you need to know how these formulas came, please watch my previous lectures. So IB, so which can be written as beta IB plus 1 plus beta ICEO, ICBO, because that only we have in question. So this is one important relation. So please make a note of it. So plenty of questions we already asked it. So beta which is equal to, we didn't know beta also. So now we have to calculate beta. So beta which is equal to alpha divided by 1 minus alpha. So which is 0.98, 1 minus 0.98. So if we calculate, we will be getting 49. So 49, we know IB which is equal to 20 microamps plus 1 plus 49 into ICEO which is equal to 0.6 microamps. So micro is common, so take a micrograms outside. And we substitute all the things like 49 into 20 plus 50 into 0.6. The total is micro. So if we do the calculation, we will be able to get 1.01 milliamps. So that is what the answer that we will be getting. So please use calculator or any kind of things to do. So I hope this is very easy. So you guys can easily solve it if you guys have the simple formula behind you. So these are not that much tricky questions. So I am in the 3 questions. If you guys know the formula and some kind of practical understanding, you guys can able to do. So if unless you didn't made any mistake in calculations. Let's go for the next question. So this is one of the very good question in the previously comparing all the things. So this is one one. So Q1, Q2 are identical transistor. So Q1, Q2 identical means all the configuration, all the current flow, everything is same. Operating in active mode, V1 is equal to V2. Then they are asking the current Ix. So they given AE which is 500. So DN, INI, NB, some many information that they are given. So we have our ultimate aim to calculate Ix. So Ix is equal to IC1 plus IC2. So from that figure, we can state that this is. So this is only we need to calculate. So please pause the video and try to answer it here. So in order to find this, we need IC. So they didn't give any information like beta, current gain, nothing they are given. So we need to use this formula to find out IC. So which is equal to EB divided by eta VT minus 1. This minus 1 can be ignored, so I am ignoring it. So then this case is equal to this. So IS also they haven't given, so we need to find IS first. So we know IS is equal to AEQ DP LP PN0. So this is in the morning class, like in the previous 4-5 class previous we have solved it, so please watch that one. So AQ DN LN, similar to diode current, we have this formula. So this is some constant. So in majority of things they will provide this thing, but here in order to twist you they haven't provided it. So we need to find out this thing. So we know that this one can be also rewritten as AEQ DE because it's in BJT, right? So emitter Ni square divided by Ne plus AEQ. Here this can be dB WB Ni square divided by NB. So this term can be completely ignored because we know that the width of the W is much greater than WB. So 1 by reciprocal we are ignoring it. So if we simply take IS which is equal to this one, we can able to find out answer. So let me write it. IS which is equal to AEQ dB divided by WB Ni square divided by WB. Sorry, NB. So this is WB. So this is WB into Ni square divided by NB. Okay. So if we substitute the thing, so AE which is equal to 500 cross, that is milli they are given. So micro, that is we are converting into the milli because that is in a meter. So we will be taking that to centimeter. So that is 10 power minus 4 cross 500 into 10 power minus 4. So this is the area. So Q can be written as 1.6 into 10 power minus 19. So all the things, if any deal they are given in question, for sure that will come. That we need to use it. So for that only they are giving. So please don't ignore anything. So even you can cross check it. So whether we are doing correctly or not with the whether we have used all the data there or not. So it is 10 power minus 4 and Ni square which is 10 power 10. So where Ni? So Ni is here. So Ni square. So that can be written as 10 power 20. So divided by NB which is equal to number 15. Okay. So let us substitute all these values. So if we think, so this can be cancelled here. So this is normal thing. So this is cancelled, and if we subtract, so this can be cancelled to 5. So we will be having the rest of things. So let me write out rest of thing. So these things can also be cancelled. So this is that, and 5, 36 is being cancelled. So if we solve the things, then we will be ending with 5 into 5, 25. So this power is a 10 power 4. So we are cancelling another one 10 power 4 also here. So which is into 1.6 into 10 power minus 19 into 35 divided by 0.5 into 10 power 5. Okay. I hope you are able to understand it. Simple normal calculation. So if we calculate everything, so we will be ending with the formula that is 28 into 10 power minus 12 amps. So IS is this one. So we have find out IS. So let's take IC. So IC1 which is equal to IC2 because it's an identical transistor. So both will be equal. So IS e power VBE divided by VT. So this is equal to, so 28 into 10 power minus 12 into e power 0.7 divided by 0.0. VT is what is the VT they are given? So VT is 26, not 25. So small change here. So that is 26. So if you use the calculator, then we will be ending with 13.7943 amps. So this is not, this is IC only. They asked to find IX. So IX is equal to 2 times of this one. So it is 2 times of IC1, or even we can add both the things. So IC1 plus IC2. So which is equal to 2 into 13.79. Okay. So this will be some 27, near to 27. Okay. So use the calculator and do it. So near to 27 amps, not milliamps. Okay. So this is how we need to apply both the formulas and how the real-time understanding that we are doing. So here you see both the transistors are joined together. We may not know how both the transistor joining will look like, But you see, the question is quite simple. So we know all the data, we know all the formula, and we have solved it. So if you guys see this question and thought this is not in our my bucket, so I haven't studied this, I am skipping, then mark you will be losing. So you need to try. So if there is anything to BJT or anything, you have to try. Need to utilize all the formulas that you need to know. So what are the data they given? We can incorporate all and we can solve it. So I hope you guys understand all these 4 problems. So these 4 problems is very important. So please watch again if you guys don't understand it. Please post any doubt if you have thing. I will be there to solve. So these are everything is gate asked question only. So I hope this is very understood for you guys. So please like, share and subscribe the channel. Stay tuned for more lectures like this. From here I am dropping off the BJT. So BJT is done. So tomorrow we will be starting with MOSFET and then MOSFET. So rest 2 things only there. So that is quite some smaller lecture only. So we won't analyze the modeling. So as like in a BJT we avoided the modeling, right? So that is covered in analog devices. So there we will be just going through how the basic fundamentals work, and then we will be skipping or we will be moving to analog devices. So there we will be discussing more on the MOSFET, MOSFET, everything we will discuss to the core. So please stay tuned guys. So please like, share and subscribe channel. So stay tuned for next MOSFET lecture. There we can master every topic in MOSFET and MOSFET. Thank you guys.